Hello everyone, this video we are covering section 10B, problem solving with geometry. First thing, measurements of angles. Let's think about how do we measure time. We use hour, minute, seconds to measure time, right? So if you want to measure how long you have been driven, then hour might be enough. You have been driving like 2 hours or 3 hours. But what if you want to measure the time that you, let's say, run 800 meters? Then maybe minutes would be more convenient, right? So what if you want to measure the time when you blink your eyes? Would a minute be able to measure the time precisely? Not really. So we need a second. So that's the reason we have 3 units for time. We know there are 60 minutes in 1 hour. There are 60 seconds in 1 minute. So there are 3,600 seconds in 1 hour. Here the same thing when we measure angles. In order to measure angles more precisely, we use 3 units: degree, minutes, seconds. We have a small circle on the right, on top of the right shoulder of the number. We use that to denote the degree. So there are 60 minutes. 1 prime means minutes. 60 minutes in 1 degree. 60 seconds. Double prime means seconds. 60 seconds in 1 minute. So there are 3,600 seconds in 1 degree. It's very similar with hour, minute, and second here. We have a degree, minute, second. 60 seconds in 1 minute. 60 minutes in 1 degree. 3,600 seconds in 1 degree. Second thing, latitude and longitude. We can locate any place on the Earth's surface by its latitude, which is the north to south position from equator, and longitude, which is east-west position from prime meridian. Where is the prime meridian? This is, so on the note, this red line, that's the prime meridian in Greenwich in England, British England. And this is the equator. We know what is the equator, right? Equator divides the globe as north hemisphere and south hemisphere. We are in the north. Let's see this red dot. This red dot is the location of Miami in Florida. Since it's in the north of the equator, so the latitude of Miami is 26 degrees north. You see what I'm saying? So this is the equator. So this is 30 degrees north. This is 60 degrees north. This is 90 degrees north. So this is a little bit lower to the south of 30 degrees. So that is 26 degrees. 26 degrees north. Since Miami is to the west of the prime meridian, the longitude of Miami is 80 degrees west. So this is the prime meridian. So this is 30 degrees to the west, 30 degrees west, and this is 90 degrees west. So Miami is to the right or to the east of this 90 degrees, so that is about 80 degrees west, 80 degrees west of the prime meridian. So with longitude and with the latitude and the longitude, we are able to determine the location on the Earth's surface. The third thing, angular size and distance. The further away an object is located from you, the smaller it will appear in angular size. Angular size is defined as the angle that it covers as seen from your eye. In order to compute the angular size, we have this formula. To make it simple, just apply this formula. Angular size equals physical size multiplied by a fraction. The numerator of the fraction, 360 degrees. Denominator of the fraction, 2 pi multiplied by the distance. What's the distance? The distance between the object and your eyeball. We are going to apply this formula later when we work on a problem in the package. Next thing, pitch, grade, and slope. We know what is slope, right? Slope is rise over run. Pitch and grade are just two another different ways to describe slope. For grade, if we have a slope and we express the number of the slope as a percent, then that is a grade. For pitch, if we could represent the slope as a ratio, then that is a pitch. For example, if the slope is 2/10 or 2/20 or 1/10 as a fraction or decimal, that's the slope, right? If we can convert the fraction as a percent, let's say 10%, then that would be the grade. That's the grade. If we convert this fraction as a ratio, 1 in 10 or 2 in 20, and that's the way we use a pitch to represent the slope. So the definition is right here. It's pretty straightforward. Next topic, Pythagorean theorem. Let's say we have a right angle triangle. A and B are the length of the two legs. Then C is the length of the hypotenuse. We know what is hypotenuse. Then the three sides satisfy this equation. A squared plus B squared equals C squared. Very simple. I believe you know that already. Similar triangles. Two triangles are similar if they have the same shape but not necessarily the same size, meaning that one is a scaled up or scaled down version of the other. Two facts about the two triangles if they are similar. You can see this triangle ABC, this triangle A prime, B prime, C prime, they are similar. For two similar triangles, corresponding pairs of angles in each triangle are equal. So angle A here equals angle A primes here. Angle B and angle B prime equal to each other. Angle C and angle C prime equal to each other. Second fact, the ratios of the side length in the two triangles are all equal. A over A prime equals B over B prime equals C over C prime. We're going to use that formula later in a problem. So let's see the package. Number one, convert 41.9 degree into degrees, minutes, and seconds of arc. So this one, the measure is given in degree, is 41.9 degree. So let's rewrite 41.9 degree as 41 degree plus 0.9 degree. That's easy, right? 41.9 degree equals 41 degree plus 0.9 degree. And we are okay with 41 degree. What about 0.9 degree? How do we rewrite 0.9 degree maybe in minutes? Here, 0.9 degree is 90% of 1 degree. Do you see that? Let me say it again. 0.9 degree is 90% of 1 degree. We know 1 degree has 60 minutes. Then how many minutes equals 90% of 60 minutes? That is 54 minutes, right? So 0.9 degree is 54 minutes. So 41.9 degree into degrees, minutes, and seconds, you would have 41 degree and 54 minutes, 0 seconds. You should choose which one? You should choose C. Okay? Try to repeat the video. Try to repeat this part and really make sense of it. Number 2, convert 108 degree 15 minutes 36 seconds into decimal form. You are given a degree in degree minutes and seconds. You need to convert it to only in degree. So this is how do we do that? If you convert a minutes to hour, do you divide it by 60? If you convert a seconds to hour, do you divide it by 3600? Same thing here. You are going to keep 108 degree. For 15 minutes, you're going to divide 15 by 60 to have the corresponding degree. For 36 seconds, you're going to divide 36 seconds by 3600 to have the corresponding degree. All right? So I would let you to do the math. You should have A, but please really do the math using your calculator. 15 over 60, that is 0.25. 1 over 4, a quarter, right? 0.25. 36 over 3600, that is 1 over 100, that is 0.01. So altogether, you have 108 here, you have 0.25 here, you have 0.01 here. So altogether, you have 108.26 degree. Number 3, if you travel from latitude 52 degree north due north to latitude 57 degree north, about how many miles have you traveled? Recall, the circumference of the Earth is about 25,000 miles. Okay. If we consider 1 degree, if you move 1 degree, how many miles that is? We know the equator is a circle, right? The equator is a circle. The circumference of a circle. That is 25,000 miles. It has a 36 degree. So if you divide 25,000 miles by 36 degree, you would have the mileage for 1 degree. You moved 5 degrees down from 52 degree north to 57 degree north. You moved 5 degree north up, not down. You moved 5 degree north to the north. You moved 5 degree up. So you moved 5 degree. Then you multiply the mileage for 1 degree by 5 degree. You have 347 miles. Number 4, find the latitude and longitude of the location on Earth precisely opposite Jerusalem, Israel. The location for the city is 31.8 degree north and 35.2 degree east. Opposite location. So for latitude, the opposite location is going to be 31.8 degrees south. So C is out, D is out. For the opposite location, the latitude must be 31.8 degree. The number of the degree is the same. It's just in the south. All right, does that make sense? 31.8 degrees south. What about the longitude? The longitude for the Jerusalem is 35.2 degree east. Then you would know the opposite location is going to be on the west, but not 35.2 degree west. Instead, you're going to use 180 degree minus 35.2 degree. that is 144.8 degrees west. If you could have a globe, find the library, use the globe to figure that out. That would help. Number 5, a wall clock has a diameter 1 foot. What's the angular size if viewed from a distance of 36 feet? So we are looking for angular size. Remember I showed you the formula. Angular size equals physical size multiplied by a fraction. The fraction numerator is 36 degrees. Denominator is 2 pi multiplied by the distance. Okay, what's the physical size? 1 foot. 360 degrees, just copy it. Denominator 2 pi, copy it. What's the distance? Distance is 36 feet. So you're going to plug in everything here and do the calculation. And you would have the angular size actually is 1.59 degree. Okay. Number 6, if a road has a grade of 8%, what's the pitch? We know both of them are the same with the slope. It's just the different forms. Grade is a percent, 8%. If we rewrite 8% as a fraction, that is 8 over 100. If we reduce this fraction, we would have 2 over 25. So the pitch is 2 in 25. We choose D, D as in dog. Number 7, what's the slope of a roof that has a pitch of 20 in 12? 20 in 12 in fraction is 20 over 12. Convert this fraction as a decimal. You have about 1.67 if you round it up. That's the slope. Number 8, a right triangle has a size of length 18 and 24. Find the hypotenuse. Okay, so hypotenuse is C. C squared equals A squared plus B squared. So A is 18, B is 24. Do the math and take the square root. Use your calculator. You would have the result is 30. Okay? So I believe you are able to do the math by using your calculator here. Just know the formula for Pythagorean theorem. Number 9, triangle ABC is similar to triangle A prime, B prime, C prime. If side A is 4, side B is 15, side A prime is 3, what's the length of B prime? The formula here we are going to apply is A over A prime equals B over B prime. I showed you the formula earlier. So you plug in the value for A, which is 4. You plug in the value for A prime, which is 3. You plug in the value for B, which is 15. You are looking for the value for B prime. You cross multiply. You have 4B prime equals 3 times 15. That is 45. So B prime is 45 over 4. B prime is 45 over 4 is C. Number 10. What's the area of a square enclosure? What's the area of a square enclosure that is 312 meters of fencing? When we look at the 312 meters of fencing, that's the perimeter of the fence. So we are given perimeter. And we know the fence encloses a square area, right? Region. So we know the perimeter for a square. This is a square. The perimeter of a square is 4 times of the size length. 4 times the size length. So if the perimeter is 312, then the length of the side would be a quarter of the perimeter. That is 312 divided by 4. You have 78. Use your calculator. So now we know the side, or the length of the side is 78. We are looking for the area. We are looking for the area of the square. We know the area of the square is the side to the power of 2, the square of the side. So that is the square of 78. Use your calculator. You know square of 78 is 684 meters square. Alright, so number 10, you're going to apply the formulas for the perimeter of a square and the area of a square. Okay, this is 10B. Thank you for watching.